Till the next 10 minutes of this video, you will able to define all this. And at the last, we have also done the derivation and use of these equations. Any object in this entire universe is in motion or at rest. Motion means a change in the position of a body with time. So, if an object changes its position with respect to a fixed point over time, then it is said to be in motion, and if it doesn't, then it is said to be at rest, also known as stationary objects. So a person walking in a park is in motion, and you, watching this video in your bed, are at rest, until you are watching this video while running a marathon. Can an object be at rest and in motion at the same time? Scientifically, yes, according to the text, it depends on the observer that you are at rest or in motion. Imagine you are traveling in a luxurious vehicle with your friend. For your friend, you are at rest, while for a one standing on the road, you are in motion, which proves that motion is relative. Let's move to physical quantities. These are divided into two, scalar and vector. Scalar quantity have magnitude but not direction, while vector quantity have both, magnitude and direction. Magnitude is the numerical value of a physical quantity, like 5, in the mass of 5 kg. Hey, it's Santosh. He used to go to his school by this blue path, while the shortest distance between his home and school is the dotted gray path. This is the major difference between distance and displacement. Distance is the total path covered, and displacement is the shortest path between starting and ending point. Usually distance is represented by d, and displacement by small s. Let's see some major differences between them. Distance is a scalar quantity while displacement is vector, means displacement have a direction but distance does not. If any object have moved, then displacement can be 0 or negative, but distance cannot. And also, if initial and final position of an object are same, then displacement will be 0. If you move in the opposite direction of a chosen reference point, then your displacement will be negative. For example, in a race if you run about 5 meters, in opposite direction of the finish line, then your displacement will be negative 5 meters. To find distance, we multiply speed with time, and to find displacement, we subtract initial position from final position, and also, we can just multiply velocity with time. But, what is speed and velocity? Speed is the measure of how quickly an object is moving. According to definitions, speed is the distance traveled per unit time. It is calculated by dividing distance by time. As distance is a scalar quantity, our speed is also a scalar quantity, means it have magnitude, but not direction. Now we have a concept of average speed. It is calculated by dividing total distance covered by total time taken. Velocity is basically speed with direction. Definition says that distance traveled by body per unit time in a given direction is known as its velocity. So velocity equals displacement by time. Displacement, vector quantity, so our velocity is also a vector quantity. So, velocity and speed are same. No, the main difference between speed and velocity is that the velocity of a moving object changes as its direction changes. So, if an object moves in a straight path without changing its direction, then its speed and velocity will be same. While, if that object moves in a circular path, then speed and velocity will be different. And, to find average velocity, we divide the sum of final and initial velocity by 2. Imagine a journey by your car. You'll see that your speed is not the same throughout the journey. This fluctuation of speed is called acceleration. Positive acceleration means speed is increasing, and negative acceleration means speed is decreasing, also known as retardation. And if there is no acceleration, means the speed is constant, which is known as uniform motion. Keep in mind that anything upward or in right is taken as positive, and anything downwards or in left is taken as negative. Now, to find the acceleration any body has shown, we use this paperwork, saying acceleration equals final velocity minus initial velocity by time. Let's do some problem solving. This stuff seems scary, but let's break down it. Question says that the bus starts from rest and attains a velocity of 60 km per hour in 10 seconds. Find the acceleration in meter per second square, and also convert final velocity in meter per second before solving. According to the question, the bus starts from rest means the initial velocity is 0. The final velocity is given as 60 km per hour, and the time is 10 seconds. They have also asked to convert final velocity into meter per second. Fun fact. To convert kilometer per hour into meter per second, just multiply the value with 5 by 18. So multiplying 60 with 5 by 18, we get 16.7 approximate. Using the formula, acceleration equals final minus initial velocity by time, we get 16.7 minus 0 by 10. So acceleration is about 1.67 meter per second square. Oh, nice drawing. It is a distance-time graph. Its x-axis represents time and y-axis represents the distance. The slope between them shows the speed of the object. Some key terms. This straight, diagonal slope means the speed is constant, hence, uniform motion. If there would be curves in the slopes, then it would be non-uniform motion. Slope, parallel to the x-axis means the distance is not increasing, #stationary object. In simple words, this graph shows motion, by telling that by the time if the distance is increasing or not. This is velocity time graph. Its x-axis represents time, and y-axis represents the velocity. And this slope is the acceleration. Straight, diagonal slope means the acceleration is constant, hence, uniform acceleration. Slope, parallel to the x-axis, means the velocity is not increasing, means zero acceleration, and slope going downwards means retardation. Fun fact. The area between slope and time is the displacement. Because, to find its area, we'll multiply velocity with time, and velocity into time equals displacement. Here we have the question, in which they have given us the condition, and asked to draw the velocity time graph, and to calculate the total distance traveled by the car. Firstly, the car was moving in a constant velocity of 20 meters per second for 5 seconds, means zero acceleration, aka, straight line. Then the car accelerates uniformly to 40 meters per second in next 5 seconds. So, our graph would something look like this. Congratulations, you got the half marks. Now to find the distance traveled, we will take the area of the shaded part, dividing this mess into two known figures. Now we see a rectangle, and a right-angled triangle. We got the area of the rectangle as 200 meters, and the area of the triangle, 50 meters. So total distance traveled equals 250 meters. You know that A equals V minus U by T. So we can write this as AT equals V minus U. By transporting U, and we got this equation. You also know that average velocity equals V plus U by 2. And velocity also equals S by T. So we can write S by T equals V plus U by 2. Replacing the value of V by U plus AT, and then calculating it further. We got our second equation. Here we have proved that V equals U plus AT. After burning my brain cells, I got T equals V minus U by A. Previously we got S by T equals U plus V by 2. Here if we replace T with this, we'll get this equation. Mathematically, A will multiply with S, and we'll get AS by V minus U equals U plus V by 2. After cross-multiplying, we get this equation. Its RHS is looking like this stuff, so we get 2AS equals V square minus U square. And if we calculate further, we get our last equation. And yeah, these are the three main equations of motion. All credit goes to this guy, who is known to discover gravity. These equations are often used to find these, in a question. Let's try one. A stone is thrown vertically upward, with a velocity of 20 meters per second. How high will it rise? According to the question, the stone was thrown vertically upward, with a velocity of 20 meters per second. Means the initial velocity equals 20 meters per second. The stone would be experiencing the Earth's gravitational pull of 9.8 meters per second square, but let's take it 10 meters per second square for easier calculation. So we get the acceleration as negative 10 meters per second square. There's asked that how high will the stone rise, means at a point, the stone would stop and start falling downwards, so the final velocity would be 0. They have asked to find how high will the stone rise, means the distance. Using this formula, we get 0 squared equals 20 squared plus 2 into negative 10s. By burning my brain cells, we got the height as 20.41 meters. This is gravity, but this is also free fall. A fall from a height under the influence of gravity without any other force acting upon is known as free fall. If a stone is dropped from the top of a tower and takes 4 seconds to reach the ground, what is the height of the tower? As the stone was dropped, the initial velocity would be 0. Time is given as 4 seconds, and acceleration will be 10 meters per second square. Using this formula, we get the height as 80 meters. Actually the height would be around 78 meters, because we have taken the acceleration as 10 meters per second, instead of 9.8. Did you know about barter system? For all this knowledge, you just need to give one like and subscribe. See you in next video.